I'm putting together for just some practice problems to get ready for the test. Our test is going to cover section 3.1 and 3.2. And it's all about these quadratics and graphing and stuff like that, so we shouldn't do too bad. Good advice on any test or any homework, always read the directions. In number 1 and number 2, you're going to use the vertex and the intercepts, plural intercepts, x and y, to sketch the graph of the quadratic function. Use the graph to determine the function's domain and range. We'll put that over here on this line. When I grade the test, I will be looking at, making sure that you cross at the exact intercept that we're looking for. So this one, number 1, our equation is given to us in standard form. So the vertex is easy enough to pluck out of that standard form. And we can see here our x-coordinate is going to be a -4, and our y-coordinate is going to be a -2. Next, I usually go after the x-intercepts. To find the x-intercepts, we want to set the equation equal to 0. So I'm going to come down here where I have a little more room. X plus 4 quantity squared minus 2 equals 0. Step 1, I'll add 2 to both sides. So now it's equal to a +2. And then now I have the squared term isolated. I will radical both sides. So now I have x plus 4 equals plus and minus the square root of 2. So one of our answers is going to be, well, and I'm going to move the minus or the 4 over to the other side, subtract it from each side. So I'm going to have a -4 plus radical 2, and I'm also going to have a -4 minus radical 2 for our two x-intercepts. So decimals will be good enough here. Let's see, I'll do 4 negative, and then I'll do plus 2 square root. So -4 plus the square root of 2 equals -2 point, well, one decimal will be fine enough here, -2.6. And now for the other one, we'll clear that out. -4 minus radical 2. 4 negative minus 2 square root equals -5.4. Okay, and last thing is y-intercept. Actually, let me, I'll transfer these up here. We have our -2.6 and -5.4. Okay, y-intercept. The y-intercept is easy. The y-intercept is f of 0. So if we plug in 0, we'll have 0 plus 4, quantity squared, and then minus 2. So 0 plus 4 is 4, and we square that and get 16, minus 2 is 14. That's going to go a little off graph, but we'll be all right. And it doesn't say it up there, but we do need to think about our end behavior, our leading coefficient test. So let's see, leading coefficient is positive, and it would be x squared if we FOIL that out. So positive squared, our end behavior is up to the left, up to the right. Because when we were doing this section, remember, these were all parabolas, so we did know that these were going to be parabolas. So first thing to graph, vertex, -4 up to -2. Two x-intercepts. Ooh. Hold on, why do we have, -4, -2, my bad. I was going to say, how could we have a vertex here and open up and if we wouldn't have any x-intercepts? -4, -2. We have two x-intercepts at -2.6, a little bit more than -2.5, and then also -5.4. Remember, that's a spot check. We should be symmetric around our axis of symmetry. The axis of symmetry will go through the vertex, and we will be reflected around that. Y-intercept, +14. That +14 would be well enough off the paper. If this was a test question and you very quickly just sketched something like that, and I saw that you did touch the x-axis somewhere in here, I would have to mark that wrong. We know our intercept is going to be up well off the graph. And then we'll open up also, I missed my x-intercept. And there we go. Domain. Remember, for any polynomial, the domain is all real numbers, negative to positive infinity. Remember, there is no chance to divide by 0. There is no radical to have a negative underneath. So all real numbers. The range. If your parabola opens up, of course, you're going to be heading toward positive infinity. How low do we go? Well, that's our vertex. Our vertex on the y-axis has a low or a height of -2. So bracket -2, comma, infinity. We can go from -2 all the way up to infinity, and that's where our parabola is defined. And I believe we have answered everything they asked for. Yes, we got a good graph, and we have the domain and range. Now, in number 1, we were given a parabola in standard form. Here's a parabola in non-standard form. But the same questions are asked. So the vertex. Here is a little more work. Remember, we had our little formula, sort of like the quadratic equation. Our vertex, the x-coordinate is -b over 2a. So negative, our b is the number in front of x, that's a 2, divided by 2 times a. A is a -1. So if I put this negative up top with the 2, that's going to be a -2 divided by -2, which is 1. So for our vertex, the x-coordinate is a 1. How do we find the y-coordinate that it goes with? F of 1. Plug this one back into the function. So that would be a -1 squared plus 2 times 1 plus 3. So we square 1 and we get 1, and this will be a -1, and then plus 2 plus 3, that would be a +4. 1, 4. So that's our vertex. X-intercepts. I'll put X-intercept here, and I'll leave some space. Of course, to find the X-intercept, we want to set the function equal to 0. The first thing I would do before I tried to factor would be to divide everything by -1. So I would switch all my signs, and 0 doesn't have a sign, so it stays 0. Okay, now can we factor that? That's a 2. Of course, the x² comes from x times x. -3, the factors that add up to -2. Well, that would be a -3 and a +1. And if we set each factor individually to 0, if I put a 3 here, I'd get 0, 3 minus 3, so that's an x-intercept. And then here, what plus 1 equals 0? Well, -1. There's my 2 x-intercepts. Okay, it's a -x², so it will be a parabola opening down, and that makes sense. We have our vertex at 1, 4. Parabola opens down, we will cross at 3 and -1. So somewhere in here has to be a y-intercept. Well, this is the easy one to find here, f of 0. Any term with an x gets zeroed out, our y-intercept is +3. So our parabola is opening down, headed off toward -infinity. So there's the graph with all the intercepts nicely marked and the vertex. Domain, all real numbers, negative to +infinity. The range, well, now we're headed down toward -infinity. So that's where we start. And then we can go up as high as the vertex on the y-axis, height of 4. -infinity, comma 4, bracket on the 4. All right, having fun. Here it just says use the equation, not the graph. Find the min and max value and where it occurs, and the function's domain and range. Well, remember, in a parabola, they either open down or up. If it opens down, we have a max value. If it opens up, we have a min. So let's see here. This parabola is -x², so it's going to open down. We are going to have a max value then. And where does it occur? Well, it occurs at the vertex. We got to find the vertex. -b over 2a will be our x value. Negative b is 14 divided by 2 times a is -1. So the negatives cancel to a positive. 14 divided by 2 is 7. So our vertex, our x-coordinate, is a 7. 7 comma something. Plug that 7 back into the original equation. So it's negative, and then we plug in our 7 and we square it, plus 14 times 7 minus 106. Well, square the 7, and it's 49, and it's negative. Plus 7 times 14 is 98, and then minus 106. 98 minus 49 is positive 49, yes, minus 106. 49 minus $1.06, negative 57. So that's our y coordinate. Okay, domain and range. Again, in the last examples, we had the graph that really made it obvious. But the domain, all real numbers, negative to positive infinity. The range. Okay, what way does this parabola open? Well, it's a negative x squared, so our parabola opens down. So when we're talking range, we're going to head down to negative infinity. How high will we go on the parabola? Well, all the way up to the height of the vertex. The height of the vertex is the y coordinate, negative 57. There we go. Number 4, now we're getting into more of the section 3.2 stuff, zeros and multiplicities. So find the zeros for this polynomial function, give the multiplicity of each, and state whether you cross the axis or touch and turn around at that zero. Well, let's see. If I set x minus 1 equal to 0, I'd add 1 to each side and get a 1. That 1 is to the first power, or that 0 is to the first power, multiplicity 1, and that means we cross the x-axis. Next one, x plus 2 equals 0. Well, what would 0? That would be a negative 2. The multiplicity of that 0 is 2, even. Even multiplicity means we touch and turn around. Touch and turn, TNT. Last 0, x plus 5 equals 0. We would subtract 5 each side and get our 0 at negative 5. Multiplicity here is 3, which is odd and means we cross the x-axis. And moving on. Number 5. This is sort of the 5-point one. We're going to fully graph this one. Use the leading coefficient test to determine the graph's end behavior. Determine whether the graph has y-axis, origin, or y-axis symmetry, origin symmetry, or neither. Just is the function even, odd, or neither. And do a nice graph of the function. Okay, where do we begin? Part A, leading, coefficient test. We have a positive leading coefficient, and it is odd. Positive and odd means our end behavior will be up to the right and down to the left. So I'll just put that in the corner of the graph. Determine whether the graph has y-axis symmetry, or origin symmetry, or neither. Let's see, it's a third power, squared power. As soon as I see one of each, an odd and an even power, it has no symmetry, neither. So as we're graphing, we're not going to be aided by knowing that we have symmetry around the y-axis or around the origin. Okay, step 2, X-intercepts. Looks like we're going to have to factor 4 terms. Leading one is a squared, so we're going to factor by groups. I'm going to work over here. The first 2 I can factor out an x squared, leaving x minus 1. And out of the next 2 terms, I can factor out a minus 9. And that will leave x minus 1. So now here, don't confuse this with multiplicity. We're factoring by grouping. The x minus 1 is one of our terms. The other term is made up of the leftovers, the x squared and the minus 9. And I hope you can see that that is a difference of squares that is further factorable. So we have x minus 3 and x plus 3 and the other factor of x minus 1. Notice these are all odd multiplicities. This is first power, first power, first power. So we will cross the axis fully at each of these zeros. What are our zeros? Well, this would be zeroed out by a positive 3. The next one by a negative 3. And the last one by a positive 1. Again, these are our 3 zeros, and they are all odd multiplicity. So let's even graph them now. Negative 3, positive 3, positive 1. And again, when I graph these, I'll do like a little line through it to show you, yeah, I can cross at that 0. If I'm graphing and that line's not there, it's even multiplicity, and I do not cross. So our x-intercepts, plus and minus 3, and positive 1. To step 3, y-intercept. This is an easy one. If I plug in zeros for all my x's, these terms get zeroed out, and my y-intercept is plus 9. And we can graph that. squeeze it in just above the graph. There we go. So we got our end behavior and our intercepts. That's really all we need. Step 4 was our symmetry. Symmetry, there is none. Ooh, I guess we could write end behavior here, right? Down, up, symmetry, none, or neither. So that was step 4, no symmetry. Step 5 was number of curves. This is a third power function, so we're going to have 2 turns or 2 curves in the graph when we're done graphing if we do everything right. So let's see. I always, start and I go left to right. Well, I know if my end behavior is down to the left, and I know I'm headed up toward my first x-intercept, and I know I'm going to cross. So I'm going to cross at -3. And I head up to a positive y-axis intercept, which makes sense. And then I head down, and I know I'm going to cross the x-axis again at 1. Now here, I don't know how low to go. Do I go way down and off the graph? Do I just go down a little bit? That is a mystery best left for calculus class. You'll get there one day. But for now, we know we're going to cross here. Now we're in the 4th quadrant, and we know we're going to turn back around because we got across again here at 3, and that will fulfill the other side's end behavior up and away to positive infinity. So that's a rough idea of the graph. We know the intercepts are good. Those are nailed down. Again, we don't know how far down or high this part of the graph goes. And let's see if we answered everything. We have our 5 steps, and behavior symmetry looks good. Alrighty. Here's another polynomial function, and this one is nicely factored for us. If we had FOILed this all out and tried to factor that ourselves, it would have been quite a bit of work. So they did a lot of the heavy lifting for us. 1, end behavior. See, it's a +2. All terms are positive, so it's positive. See, we have an x squared, another cubed, and this would be a first power. Multiply bases, add exponents. That adds up to a 6. So it's positive and it's even. End behavior for positive even is up both ways, up to the left, up to the right. We are going to have 3 zeros. I can see just by looking at the terms. If I set this equal to 0, it's going to be 2x squared equals 0, and we'll divide by 2 and square root each side and get a 0 at x equals 0. And let's see, the multiplicity is 2, so we are going to not cross the x-axis. We're going to touch and turn around at 0. Our next 0 would be the next term. X minus 1 equals 0 would add 1 to both sides and get a 0 at x equals +1. And that is odd multiplicity, so we're going to cross. Last term, x plus 2 equals 0. Subtract 2 from each side. X is -2. Odd multiplicity, first power, so we will also cross. So right now, let's even graph those on there. At 0, we're going to hit the x-axis but not cross, touch and turn around. At +1 here, we're going to cross, so I draw a little line through it. At -2 is another x-intercept, and we're also going to cross. What else do we need? 3. We could find the y-intercept. All x's become 0. So that's going to be 2x squared becomes a 0 times, in this parentheses, 0 minus 1 will be 1 cubed. And the last one will be 0 plus 2 is 2 to the first power. The leading 0 wipes it all out. Our y-intercept is, well, I guess, yeah, it should have been obvious. If we're going through the x-axis at the origin, that's our y-intercept also. You can only have one y-intercept in a function. Number 4, symmetry. Just looking by the x-intercepts here, we do not have x or y-axis symmetry or origin, so no symmetry. For number 5, if it was a 6th power function, we should have 5 turns when we graph. Let's see if everything works out. We're up here to the left. Our function goes up to infinity, so we're headed back down this way, and we will cross at -2. As we head left to right, we're getting pulled toward we know we have a y or x-intercept at the origin, but we're not going to cross, we're going to bounce. And we bounce off there. Immediately, we're going to cross the x-axis at 1, so we're going to head right back up here. And our end behavior is up to the right. So it looks like that. Again, we don't know. Maybe this goes way, way down deep before it comes back up. Maybe it's just real subtle underneath the x-axis. That part we're not sure of. As over here, we don't know how far down we go. The x-intercepts are nailed down for sure, so we got a general idea, but again, it's not perfect. All right. Is that all they asked for? End behavior symmetry. Yeah, we got the graph down good. And that's it. I just have some blank slides on here, so I hope that helped get you ready for the test tomorrow.